Mastering the Power of AI. Your journey continues. Welcome to part 2 of your AI journey. If you've made it this far, congratulations. You're already ahead of the curve. In this segment, we're diving straight into the heart of AI. This is where the magic becomes reality. We'll break down the fundamentals of artificial intelligence and machine learning, showing you how machines think, learn, and make decisions. You'll also discover how to apply what you've learned to real-world projects, turning your knowledge into practical skills. Whether you're here to build the next groundbreaking AI application or simply learn how to solve complex problems, this part will give you the tools to do just that. So grab your notebook, stay focused, and let's unlock the power of AI together. The future is yours to create. AI versus machine learning. Now that you've mastered the basics of math and programming, it's time to dive into the heart of AI. But before we begin, let's clarify something that often confuses newcomers: the difference between artificial intelligence, AI, and machine learning, ML. AI is the broader concept. It's about creating systems that mimic human intelligence. This includes everything from robotics to natural language processing. Machine learning, on the other hand, is a subset of AI focused on algorithms that learn from data. It's how systems like recommendation engines, predictive models, and voice assistants improve over time. For self-learners, you don't have to pick just one. You can explore both, starting with AI fundamentals and then diving deeper into machine learning. Here's how to structure your learning. AI Basics, building the big picture. AI covers a wide range of topics, and understanding its fundamentals will give you a strong foundation for more specialized areas. Key topics to explore include constraint satisfaction, how AI solves problems with defined limits like scheduling tasks or planning routes. Markov decision processes, MDPs, understanding how systems make decisions under uncertainty, like how a robot decides which path to take. Logic and knowledge, representation, the rules and structures AI uses to think logically and reason through complex scenarios. Start with courses like MIT's Introduction to AI, which offers free lectures and comprehensive notes. Stanford's Logic series, available on YouTube, is another excellent resource. These courses will introduce you to the concepts that underpin almost every AI system. Machine learning is where the magic happens. It's about creating algorithms that allow machines to learn patterns and make decisions without being explicitly programmed. There are 3 main types of learning. Supervised learning, training models on labeled data to make predictions, for example, identifying spam emails. Unsupervised learning, finding patterns in unlabeled data, for example, clustering customer preferences. Reinforcement learning, teaching systems to make decisions through trial and error, for example, training a robot to navigate a maze. Resources like Coursera's Machine Learning Specialization by Andrew Ng and FastAI's Practical Deep Learning for Coders are great places to start. Both offer hands-on projects, which are crucial for solidifying your understanding. Theory is essential, but projects are where you truly learn. Projects allow you to apply what you've learned, solve real-world problems, and build a portfolio that demonstrates your skills. Here are some project ideas to get you started. Predict stock prices. Use historical data to forecast market trends. Image classification. Train a model to recognize objects in photos. Chatbots. Build an AI that can carry on basic conversations. Reinforcement learning games. Create an AI agent that plays games like tic-tac-toe or chess. For inspiration, check out Kaggle competitions or browse through Stanford's archived student projects. You'll find plenty of examples to spark your creativity. The fundamentals you learn in this phase have far-reaching applications. Consider these examples. Healthcare. AI models predict diseases based on medical imaging. Finance. Machine learning algorithms detect fraudulent transactions. Retail. AI personalizes shopping experiences with recommendation systems. Every project you complete brings you closer to contributing to innovations like these. Understanding AI fundamentals isn't just about passing exams or building impressive projects. It's about grasping the why behind the what. Why does a recommendation engine suggest one product over another? Why does a chatbot respond differently to various queries? When you understand the fundamentals, you're not just using tools, you're creating them. You're positioned to innovate, push boundaries, and solve problems that no one has tackled before. And if you haven't already, subscribe to the channel for more guides and insights. We're diving into advanced topics next, and trust me, you don't want to miss it. Congratulations! By now, you've built a strong foundation in math and programming and gained an understanding of AI and machine learning fundamentals. But this is just the beginning. Next, we'll explore how to specialize and take your skills to the next level. Are you ready to unlock the advanced world of AI? Let's move on to Phase 4, specializing with electives. Why specialization matters. Now that you've built a solid foundation, it's time to dive into specialized areas of AI. Think of this phase as choosing your superpower. AI is an incredibly vast field, and while understanding the basics is essential, specializing allows you to focus your efforts, master a specific domain, and stand out in the job market or academic world. Imagine AI as a giant tree. The trunk represents the foundational knowledge you've just gained, but the branches, specialized fields like deep learning, natural language processing, NLP, computer vision, and robotics, are where the real growth and innovation happen. Let's explore the most impactful areas you can specialize in and how to get started with each. Deep learning is a subset of machine learning that mimics the human brain through artificial neural networks. It's the driving force behind some of AI's most impressive advancements, from self-driving cars to voice assistants like Alexa and Siri. Key topics to explore include neural networks, understanding how layers of neurons process data and make decisions. Backpropagation, the process of optimizing neural networks by minimizing error. Convolutional neural networks, CNNs, used for image recognition tasks. Recurrent neural networks, RNNs, ideal for sequence data such as time series or language. To get started, check out Stanford's CS231N. Convolutional neural networks for visual recognition, available for free online. For a more beginner-friendly approach, FastAudi's Deep Learning for Coders offers a practical introduction with hands-on projects. Want to apply your knowledge? Create an AI model that can classify objects and images or generate artistic renditions of photos. These projects showcase the creative and technical potential of deep learning. NLP is the field of AI that focuses on enabling machines to understand, interpret, and generate human language. It's what powers chatbots, translation tools, and sentiment analysis systems. Some key topics include text pre-processing, tokenization, stemming, and lemmatization to prepare data. Word embeddings, representing words as vectors, for example, word2, vec glove. Transformer models, the architecture behind modern NLP tools like GPT and BERT. Sentiment analysis, understanding emotions and opinions in text. Start with Andrew Ng's deep learning specialization on Coursera, which includes an NLP module, or explore OpenAI's documentation on GPT models. A fun project idea? Build a sentiment analysis tool to classify positive and negative reviews for products or movies. NLP is especially exciting because it bridges the gap between humans and machines, making technology more intuitive and accessible. Computer vision is the branch of AI that enables machines to interpret and understand visual information from the world. It's the technology behind face recognition systems, augmented reality, AR, and even autonomous vehicles. Areas to focus on: image processing, techniques for enhancing and analyzing images. Object detection and recognition, identifying and labeling objects and images. Image segmentation, dividing an image into meaningful regions for analysis. Generative models, creating new images using AI such as deepfakes or art generators. Stanford's CS231N is an excellent starting point for computer vision, and the OpenCV library provides practical tools to experiment with. For a project, try creating an AI that detects faces or recognizes handwritten digits. If you're fascinated by the idea of machines interacting with the physical world, robotics might be your calling. Robotics combines AI with engineering to build intelligent machines capable of sensing, thinking, and acting. Core topics include path planning, how robots determine the best route from point A to point B. Sensor integration, using cameras, LiDAR, and other sensors to perceive the environment. Reinforcement. Learning, training robots to make decisions through trial and error. Robotics is a multidisciplinary field, so you'll also need some knowledge of physics and control systems. Free resources like MIT's Introduction to Robotics or OpenAI's reinforcement learning guides are great places to start. Try building a simple robot using Arduino or Raspberry Pi and integrate it with AI for tasks like obstacle avoidance or line following. Reinforcement learning, RL, is an area of AI that focuses on training agents to make decisions by interacting with an environment. It's the technique behind AI agents that play games, control robots, and even optimize financial portfolios. Key concepts include Markov decision processes, MDPs, a framework for decision-making under uncertainty. Policy and value functions, how agents evaluate and choose actions. Deep reinforcement. Learning, combining RL with neural networks for more complex tasks. Check out OpenAI's tutorials or David Silver's reinforcement learning course at DeepMind. For a fun project, train an AI to play a classic video game like Pong or Pac-Man. Watching your agent improve over time is incredibly rewarding. With so many options, how do you decide which path to take? Ask yourself, what excites you the most? What industries or applications are you passionate about? What are your long-term career goals? If you're unsure, start with a broad exploration and narrow your focus as you gain experience. The beauty of self-learning is that you're not confined to a single path. You can explore multiple fields and discover where your talents truly shine. Electives are more than just a way to specialize. They're your opportunity to make an impact. By focusing on a specific area, you're positioning yourself as an expert in a field that's driving the future. And remember, AI is constantly evolving. Staying curious and committed to lifelong learning will ensure you remain at the forefront of this exciting field. You've come a long way, but this is just the beginning. You now have the tools, resources, and roadmap to start your AI journey. Whether you're diving into deep learning, NLP, or robotics, the possibilities are endless, and so is your potential. Learning AI might seem daunting, but with the right roadmap, it's entirely possible. I've compiled everything you need into a free 15-page guide. Download it below and start your journey today. And if you're ready for the next step, watch this video. It's packed with tips to take your learning even further. If you haven't subscribed to the channel yet, now's the perfect time. Stay tuned for more in-depth guides, project ideas, and insights that will keep you inspired and moving forward. The future of AI is bright, and you're now part of the story. Let's keep